Hello, everyone, and welcome to this educational video where we'll be diving into the fascinating discovery of the positive charges in an atom. We'll explore the groundbreaking work of the German physicist Eugen Goldstein and how his experiments laid the foundation for our understanding of atomic structure, particularly the existence of positive charges, which are key to understanding the nucleus of an atom. Background context. Before we jump into the details of Goldstein's experiment, let's quickly review the structure of an atom. Atoms are the fundamental building blocks of all matter, and we now know that they consist of a dense central nucleus made up of protons and neutrons surrounded by electrons. But in the late 19th century, scientists were still unraveling these details, especially the discovery of positively charged particles. At that time, electricity was already being used to probe the structure of matter. Cathode ray tubes, a key tool for these investigations, were commonly used by scientists to study electric currents in gases. Part 2, Goldstein's experiment and the discovery of positive rays. Now let's talk about Eugen Goldstein and his groundbreaking experiment. Goldstein's contribution began with his curiosity about the existence of positive charges within the atom. He set up an experiment using a discharge tube, a sealed glass tube filled with gas at extremely low pressure, and applied a high voltage of about 10,000 volts across its electrodes. One electrode was a perforated cathode, which means it had tiny holes, and the other was an anode. So, what did he observe? When the high voltage was applied, something remarkable happened. A faint red glow appeared behind the perforated cathode. But what was causing this glow? Goldstein realized that when the high voltage was applied, it generated an electric field that accelerated the few ions present in the gas. As these ions moved through the tube, they collided with the gas atoms, knocking off electrons and forming more positive ions. These positive ions, in turn, collided with other gas atoms, creating even more ions in a cascading effect. Now, here's the key. These positive ions were attracted to the negatively charged cathode, but because the cathode had holes in it, some of these positive ions passed through to the other side of the tube. These streams of positive ions became known as canal rays or anode rays. Goldstein referred to them as canal rays because they passed through the channels or canals in the cathode. While they didn't originate at the positive electrode or anode, they were still referred to as positive rays because they carried a positive charge. This was significant because it provided clear experimental evidence of positive charges within matter, complementing the earlier discovery of electrons by J.J. Thomson, who had proved the existence of negative charges in atoms. Part 3, Importance and Impact of Goldstein's Work. Goldstein's experiment was a crucial step in understanding the structure of the atom. It demonstrated the existence of positively charged particles, which we now know as protons. This discovery paved the way for future experiments that ultimately led to the development of the nuclear model of the atom. Later scientists, including Ernest Rutherford, would build on this knowledge, leading to the discovery of the atomic nucleus, where these positive charges, or protons, reside. The discovery of Canal rays was more than just a milestone in atomic theory. It was the start of our journey into the subatomic world, showing that atoms are not indivisible as once thought, but contain smaller particles with distinct charges. In conclusion, Eugen Goldstein's pioneering work on positive rays helped shape our understanding of atomic structure. His experiment provided clear evidence that atoms contain positive charges, and his discovery of Canal rays laid the groundwork for future breakthroughs in nuclear physics. Understanding these historical experiments gives us insight into how scientific knowledge evolves over time, each discovery building upon the last, helping us piece together the complex and fascinating puzzle of the universe. Thank you for watching this video. Be sure to like, subscribe, and hit the notification bell for more videos that explore the wonders of science and the incredible world around us. See you next time.